All right, so you know I love a good space mystery. And, well, this one involves our very own star, the sun.
Oh, yeah.
We are taking a deep dive into the latest from the Solar Orbiter mission, and get this, we're talking the sharpest images of the sun's surface ever captured, ever. We're going to zoom in on sunspots, untangle the secrets of the solar wind, and even get a glimpse of how the sun's magnetic field shapes everything around it.
You know, it's incredible. It really is incredible how much the sun impacts our lives here on Earth, even from 93 million miles away. Like just by studying these images and data from the solar orbiter, we're not just learning about our own star, we're getting clues about how stars work throughout the universe.
Okay, so the solar orbiter is giving us a front row seat to the sun's photosphere. That's the visible surface we all know and love. But what's really cool are these details called granules that we're seeing for the first time in such high resolution. They're like, giant bubbles of plasma, each one spanning hundreds of miles.
Yeah, and it's kind of like when you watch a pot of water boil and you see those bubbles rising and falling. It's like, but on an astronomical scale, that's convection in action. Hot plasma rising from the sun's core, cooling at the surface, and then sinking back down. It's constant churning. That's how the sun transports heat and energy.
Now, amidst this bubbling sea of plasma, you can't miss those dark patches, the sunspots. They look almost calm, but they're actually a sign of some pretty intense magnetic activity, right?
Exactly. Think of the sun's magnetic field as a giant tangled web, and sunspots are like knots in this web. These tangled magnetic fields disrupt the normal flow of plasma, kind of like creating a bottleneck. And since that hot plasma can't rise to the surface as easily, the sunspot appears cooler and darker.
Okay, that makes sense. But it's not just about the temperature difference, is it? I mean, these magnetic fields are doing a lot more than just creating a few dark spots.
Oh, you're right. You're absolutely right. The sun's magnetic field plays a huge GE role in shaping its behavior. It's what drives those massive solar flares and coronal mass ejections that send blasts of energy and particles out into space.
Ah, so we're talking about the solar wind, that constant stream of charged particles that actually reaches us here on Earth, right? And I've heard it can have some pretty interesting effects.
Absolutely. Sometimes those effects are beautiful, like the auroras that light up the sky near the poles. But the solar wind can also be disruptive. Like imagine those coronal mass ejections, like a giant sneeze from the sun hitting Earth. That surge of energy can knock out satellites, disrupt GPS and communication networks, even cause power outages.
Wow, that's a sobering thought. So understanding the sun's magnetic field and those sunspots isn't just about satisfying our scientific curiosity. It's about protecting our technology and infrastructure here on Earth.
Precisely. And that's why the solar orbiter's magnetic field map is so valuable. It gives us a detailed view of the sun's magnetic landscape, showing us where those intense magnetic fields are concentrated and helping us predict potential solar storms.
So it's like having a weather forecast.
Mm-hmm.
But for space weather, that's pretty amazing. But hold on. There's another image that I found fascinating. The one that shows how material on the sun's surface is constantly moving. It's called a tachogram, right?
Yes, the tachogram is like a snapshot of the sun's motion. It uses color to show us how material is flowing. Blue areas are moving towards the spacecraft, and red areas are moving away. What's really fascinating is that we can see how material is being flung out around sunspots, giving us clues about how the solar wind is generated and why it travels so fast.
It's like the sun is constantly throwing these little parties around the sunspots, with plasma swirling and shooting off in all directions.
That's a great way to visualize it. And by studying these patterns of motion, we can start to understand the complex forces at play on the sun's surface. It's like unraveling a cosmic dance.
Speaking of cosmic dances, what about that breathtaking image of the sun's corona? That ethereal outer atmosphere. It looks so delicate in the pictures, but I know it's anything but calm.
Yeah, the corona is a region of extremes. It's incredibly hot, millions of degrees hotter than the sun's surface, and it's where the solar wind gets its final push out into space. The images from solar orbiter show us these delicate-looking strands of plasma, tracing out the sun's magnetic field lines.
It's almost as if we're seeing the sun's magnetic skeleton, and those field lines are like highways for the solar wind to escape.
Exactly. And those escaping particles, they eventually reach us here on Earth, interacting with our planet's magnetic field. That's what creates those beautiful auroras. But it can also trigger those geomagnetic storms we were talking about earlier.
Yeah.
So understanding the corona is crucial to understanding how the sun affects us here on Earth.
Wow. I'm starting to realize just how interconnected everything is. The churning plasma on the sun's surface, the magnetic field lines, the solar wind, and even those beautiful auroras dancing in the sky. It's all part of this incredible dynamic system.
And solar orbiter is giving us a whole new perspective on this system.
Now, speaking of new perspectives, I hear that Solar Orbiter is on a mission to capture images of a region we've never seen before.
That's right. In early 2025, Solar Orbiter will reach a higher inclination, allowing it to capture the first ever images of the sun's poles.
The sun's poles, that's incredible. What are you hoping to learn from those images?
Well, the sun's poles are thought to play a crucial role in the solar cycle, that 11-year period of fluctuating activity. By observing the poles, we hope to gain a better understanding of how the sun's magnetic field flips polarity every 11 years, a phenomenon that drives those solar storms and affects our planet.
So we're talking about getting a glimpse into the very heart of the sun's magnetic dynamo. That's absolutely mind-blowing. But before we jump ahead to 2025, let's take a closer look at what we've already learned from the Solar Orbiter's recent observations.
A great idea. These high-resolution images of the photosphere, those tangled magnetic fields around sunspots, the swirling motions in the tachogram, and that ethereal view of the corona, they're all pieces of the puzzle.
And each piece helps us understand how this massive ball of plasma, 93 million miles away, can have such a profound impact on our lives here on Earth.
Exactly. And remember, this is just the beginning. Solar Orbiter will continue to orbit the sun, gathering more data and capturing even more detailed images.
Well, I, for one, can't wait to see what other secrets the sun reveals.
Me neither. And who knows, maybe these discoveries will inspire the next generation of space explorers and scientists.
Speaking of inspiration, what can our listeners do to explore these amazing images for themselves? I mean, I'm already itching to take a closer look.
Well, you're in luck. We'll be sure to include links to all the images and resources mentioned in this deep dive in our show notes. You can zoom in on those incredible granules, trace those magnetic field lines, and even watch those mesmerizing tachograms in action.
That's fantastic, because I have a feeling our listeners are just as captivated by these solar revelations as we are.
I have no doubt. And remember, this is just a glimpse into the vast and complex world of solar science. There's still so much to discover, so many mysteries yet to be unraveled.
And with missions like Solar Orbiter constantly pushing the boundaries of what's possible, who knows what incredible insights await us in the years to come.
Indeed. The sun, our nearest star, still holds countless secrets.
All right, you've definitely piqued my curiosity even more. But for now, we need to take a short break. When we come back, we'll dive deeper into the implications of these discoveries and what they mean for our understanding of the sun. So stay tuned, space explorers. We've got much more to uncover.
Welcome back. It's amazing to think about all the information we're getting from these images, isn't it?
It really is, and I'm still reeling from the fact that we're about to see the sun's poles for the very first time. But before we get lost in the future, let's talk a little more about those incredible mosaics we were discussing. They're not just single snapshots, are they?
You're right. You might be surprised to learn that each mosaic is actually composed of 25 individual images, each capturing a tiny portion of the sun.
Wait, 25 images for one mosaic? Why so many?
Well, because Solar Orbiter was so close to the sun, each individual image only covered a small section of the solar disk. Imagine trying to photograph a giant beach ball from just inches away. You'd only capture a small patch at a time. To get the whole picture, they had to tilt and rotate the spacecraft to capture different areas of the sun's surface, and then carefully stitch those images together.
So it's like creating a giant jigsaw puzzle, but with cutting-edge technology and the sun as the subject. That's dedication, and they're going to have to employ those same techniques when Solar Orbiter reaches a higher inclination and can finally capture those elusive images of the sun's poles, right?
Absolutely. It's a testament to the ingenuity of the mission team. But think about the payoff. Getting those polar images in 2025 will be groundbreaking.
It really makes you appreciate the effort and precision that goes into these missions. It's not just about sending a spacecraft up there. It's about having the vision and the technical know-how to capture those truly unique perspectives.
Exactly. And the results are well worth it. Imagine the insights we could gain from studying those polar regions, especially when it comes to understanding the solar cycle.
Speaking of insights, what are some of the key takeaways you hope our listeners will walk away with after this deep dive?
I think one of the most important things to remember is that the sun is not just a static ball of light. It's an incredibly dynamic and complex system, with constantly changing magnetic fields, swirling plasma flows, and explosive events that can impact us here on Earth.
And as we've seen, understanding those processes isn't just about satisfying our scientific curiosity. It has real-world implications for our technology, our infrastructure, and potentially even our safety.
Absolutely. And it's not just about us either. The sun's influence extends throughout the solar system, shaping the environments of planets, moons, and even the space between them.
So what we're learning about our own sun helps us understand the countless other stars scattered throughout the cosmos. It's really about unlocking the secrets of the universe, one image at a time.
That's a great way to put it. And it's important to remember that even with these amazing images and data from Solar Orbiter, we're still just scratching the surface. There's so much more to learn about our sun. And with each new discovery, we get a little closer to understanding our place in the grand scheme of things.
On that note, any final thoughts or words of wisdom for our sunstruck listeners before we wrap up our deep dive today?
I'd say this: never stop looking up and never lose your sense of wonder. The sun is a constant source of fascination. And with every new mission and every new discovery, we get to experience that awe and excitement all over again.
Beautifully said. And who knows, maybe one of our listeners will be inspired by these images to make their own groundbreaking discoveries someday.
Wouldn't that be amazing?
Mhm.
The future of space exploration is bright. And I have a feeling there are many more solar surprises waiting to be uncovered.
Well, on that note, I think we've reached the end of our deep dive for today, but I have a feeling this conversation about the sun is far from over.
Absolutely not. It's a topic that will continue to fascinate and intrigue us for generations to come.
A huge thanks to you for illuminating this journey for us today.
My pleasure. Always happy to share the wonders of the cosmos.
And to our listeners, thanks for joining us on this deep dive into the heart of our solar system. Until next time, keep looking up and stay curious. It's funny, we often take the sun for granted, this giant ball of fire in the sky. But after this deep dive, I'm looking at it with a whole new sense of awe.
Yeah, it really is true. The sun is so familiar to us, yet it holds so many mysteries. And it's a constant reminder that there's always more to learn, even about the things we think we know best.
And speaking of learning, I have to ask, for those of us who aren't astrophysicists, what's the best way to really grasp the scale and complexity of what we've been talking about? It's one thing to see a picture of a sunspot, but it's another to really understand the forces at play.
That's a great question. One thing I always tell people is to try to visualize it. Imagine yourself standing on the surface of the sun, surrounded by this ocean of boiling plasma. Feel the intense heat, the powerful magnetic fields, and the sheer energy of it all. It's a humbling experience, even just in your imagination.
Okay, I'm trying to wrap my head around that. I'm feeling pretty small right now. But it does give you a sense of perspective, doesn't it?
It does, and it reminds us that we're part of something much bigger than ourselves. The sun is the center of our solar system, the source of energy that sustains all life on Earth. It's a force of nature that we can't control, but we can strive to understand it better.
And that understanding is more important than ever, especially with the increasing reliance on technology that's vulnerable to the solar storms we talked about.
Exactly. The more we know about the sun, the better equipped we are to protect ourselves from its potential disruptions. It's like knowing the forecast. If you know a storm is coming, you can take steps to prepare.
So we're not just passively observing the sun, we're actively learning how to live with it, how to adapt to its rhythms and its sometimes unpredictable behavior.
That's a great way to put it. It's a partnership in a way.
Mm-hmm.
We depend on the sun for life itself, but we also need to respect its power and learn how to coexist with it safely.
Well said. Any final thoughts for our listeners before we wrap up this incredible journey into the heart of our solar system?
I just encourage everyone to keep exploring, keep asking questions, and never lose that sense of wonder about the universe around us. We've only just begun to scratch the surface of what there is to discover.
And maybe, just maybe, some of those future discoveries will come from the curious minds listening to this very deep dive. So to all our listeners, thank you for joining us. Keep looking up and keep those questions coming. Until next time.